Alright, so we've learnt how to factorise by finding common factors. You pull those out the front, and then we've got some terms in the brackets. We've looked at the PSF method for factorising when it comes to quadratic trinomials, whether they're monic or non-monic quadratic trinomials. And then now we've got another way of factorising quadratics, which is by completing the square. And this all relies on the fact that we know that if we have a plus b all squared, that will end up with a squared plus 2ab plus b squared. Also, another thing that we're going to be relying upon is that we have a minus b all squared. That will give us a squared minus 2ab plus b squared. These should both be b squared terms. And the other one that's going to be relied upon is this expression where we have a difference of two squares, a plus b times a minus b. That will give us a squared minus b squared. We're going to be relying on these three bits of knowledge. So let's get started with an example. So for example 1, take an expression of x squared plus 4x plus 1. Now, you might think that you can factorise that, but there is no way that you'll be able to factorise that using the PSF method. So we're going to factorise this by completing the square. Now, the way we do this is we're going to look at the term in front of, or we're going to look at the coefficient in front of the x. And for the moment, you just need to follow this process, and your understanding of why we do this process will come in time. What we're actually going to say is that's equal to x squared plus 4x. Now here's where the strange bit comes in. We're going to halve this 4. Half of 4 is 2. And then we're going to square 2, which is 4. So we're going to add 4 into this expression. But now that we've added 4, we've actually changed the value of the whole expression. So we're immediately going to subtract this 4 away. Now it seems strange, but that's just the process we follow. And then we have the plus 1 at the end. Now, because we added that 4, this part of the expression, we added the 4 here, which was a half of this squared. The part of the expression in the brackets, that is now a perfect square. So what I know for certain is that this will be x plus 2 all squared. And now we have to address the final part of the expression, minus 4 plus 1. Minus 4 plus 1 is minus 3. And what we'll find is that if we're a little bit creative and remember that this 3 here, we can think of it as being the square root of 3 all squared. So really what we have is x plus 2 all squared minus the square root of 3 all squared. And looking at that, we actually have a difference of 2 squares. Remember this thing up the top here? That's what's important, is we've got a difference of 2 squares. And we can factorise that. So I'm going to need a fresh page. And remembering that we've got a difference of 2 squares, really what that means is when we factorise this expression, we're going to have 2 sets of brackets, and it will be the first term, which is this bit here, that goes in the front of the brackets. That's x plus 2. Put x plus 2. And we'll have a plus term and a minus term when it's the difference of 2 squares. And then we'll have the second term, this root 3 here, which goes in the second part of the brackets. So we'll have root 3 and root 3. Now, there's some internal brackets there, the brackets that are around the x plus 2, and we can remove those brackets so that we end up with x plus 2 plus root 3 and x plus 2 minus root 3. Okay, that's the first example.